Alright, today we're going to do lesson 50, and that includes decimal numbers on a line, and we're going to go by tenths, and we're also going to do dividing by a fraction. So without further ado, let's start. Alright, so let's talk about the number line really quick. The number line goes forever in the positive direction, so here I only have two whole numbers, 1, 2, but if it kept going, which it does because it has an arrow, and all lines have arrows and indicating that they go into infinity. I would keep going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into infinity. And then we also have the negative side, and that's to the left of 0. Whole numbers go all the way to negative infinity as well. But I want to talk about a different type of number that's on the number line, decimal numbers. And decimal numbers are going to come. A lot of times we don't indicate them, or we don't note them, but sometimes we definitely need to note them. So we're going to go ahead and put tick marks right here. So this is, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this right here, these tick marks indicate tenths because there's 10 of them in between the 0 and the 1. Okay, so we're going to go, this first one is going to be 1/10. You can also write that as 0.1. Alright? This one right here is going to be 5/10. And we'll use 0.5 to indicate the big tick mark. I'm clearly going to run out of room on all of these, but each tick mark is another tenth. So you start at 0 and you count 1/10, 2, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and of course 10/10 is the same as 1, because we know that anything over itself is 1. Alright, so here is an example problem. What would be the measure of a point if it was right there on the number line? So we're going to start at 0. Well, it's definitely a positive number. It's definitely a decimal number because it's not a whole number, because it's in between 1 and 2. So we're going to put that this one right here is 1, and let's count how many tenths. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. And there's the announcements. So this would be 1 and 6/10. Alright, let's move on to the next concept. Dividing by a fraction. How many quarters are in $3? Here's a problem. A lot of people can do this in their heads. They think, okay, I know how many quarters are in $1. That would be 4 quarters in $1. And then they would think to themselves, well, this is $3, so that would be 4 quarters for the first dollar, 4 for the second, 4 for the third, which would be 4 times 3. So the answer would be 12 quarters. Okay? That's the answer, 12 quarters. But there is a different way that I think you guys really need to learn in order to get good at this, and I'm going to show you that alternative method. So basically what we're saying is we have $3, and we're going to divide that by a quarter, which is the same as 1/4. Now let's do a side lesson to review something really quick. Now we know that if we take 3 times 1/4, that's pretty easy. You guys know how to multiply fractions. So I'm going to say 3, whole number, can't multiply it, but that's easy. All you have to do is put it over 1. You guys know that little trick. And then you take 3 times 1, which is 3, 1 times 4, which is 4. You guys know how to multiply fractions. Keep that in mind. We're going to use this in just a second. Now, dividing fractions, you can't just divide across like you can multiply. You have to change this to a multiplication problem. So, first thing I'm going to do, of course, is I'm going to put 3 over 1. Then I'm going to do a little algorithm I call keep, change, flip. K, C, F. Keep, change, flip. Okay? Now I'm going to keep the first fraction, so rewrite it because you're keeping it. Then I'm going to change the division to multiplication, and you can change division to multiplication if you flip or get the reciprocal of the last fraction. So this is going to be 4 over 1. Then you multiply straight across. 3 times 4 is 12. 1 times 1 is 1. So you know that 12 over 1 is 12, which was our original answer. So this method works. Let's do a couple more practice problems. Alright, here's another problem. The diameter of a penny is 3/4 of an inch long. So if you see a penny, diameter is distance across. So the distance across one penny would be 3/4 of an inch. Alright, so if I had a bunch of pennies lined up, how many pennies would it take to make a row of pennies that is 6 inches long? Basically what you have, if you had a row of pennies, each penny having a diameter, you'd have a diameter as a line segment. So each of these line segments would make up the entire 6 inches. Now how many of these 6-inch or these 3/4 inch line segments are needed to get to 6 inches? Quickly what you start to see develop is a division problem. So here's one line segment, which is a penny, 2 line segment, so on and so forth. Alright, so since this is a division problem, I'm going to take 6 and I'm going to divide it by 3/4. Alright, this is difficult unless you know a couple tricks. One of the tricks being change a whole number to a fraction. You guys know this one. You just put it over 1. Then you use the algorithm, KCF. Keep, change, flip. You keep the first fraction. And KCF, a lot of people think Kentucky Fried Chicken. Whatever. If chicken helps you remember, more power to you. So keep the first one exactly the same. Keep meaning keep it the same. So 6 over 1. Change the division sign to a multiplication sign. Then we're going to flip this one. And that means flip is get the reciprocal. So that would be 4/3. Alright, then you multiply straight across. You guys don't know how to multiply fractions. 6 times 4, 24. 1 times 3 is 3. Okay? Now you just do simply top divided by bottom. 24 divided by 3 is 8. So you would need 8 pennies. Write that out real quick. 8 pennies to get a row of pennies that is 6 inches long. Alright, here's a little bit of homework help. Problem number 2 on your homework. 6 divided by 3/8. You're going to put 6 over 1. Then you're going to do keep, change, flip. Keep the first one, 6 over 1. Change that to multiplication and get the reciprocal, which is the same as flipping the last fraction. So that would be 8/3. Okay? 6 times 8 is 48. Then you're put 3 if you need to. Do top divided by bottom. 48 divided by 3. 1 is 3. Subtract 1. Bring down your 8. So your answer is going to be 16 boxes. Alright, here's number 3. Remember you got to add zeros. And then once you add as many place values as there are on this side, then you can see that 3 and 400 thousandths is bigger than 389 thousandths. Same with this one. We're going to add a 0 and you can see that they're equal. So there's number 3. Alright, I like this problem. First you have to combine like terms. Well, it's algebra, but before you get rid of this stuff, you have to combine like terms. 7.5 plus 2 is going to be 9.5 plus w equals, and the square root of 100 is 10, so you can go ahead and evaluate that. Then you subtract 9.5 from both sides. 9.5. So you're going to have to borrow, and all you're going to have left after that cancels out is w equals 5/10. Alright, number 5. First thing you have to do is combine like terms. 7.25 plus 2 is 7 and 25 hundredths, so that's going to be 9 and 25 hundredths plus w equals square root of 100. Then you do algebra. The square root of 100 is 10, Subtract 9 and 25 hundredths from both sides. Subtract. Alright, so this is going to cancel. All you have left is W on that side. On this side, all you're going to have left is 75 hundredths. Alright, next one. 6 times W equals 144 thousandths. 6 and W are multiplied by each other. What's opposite multiply? Divide. So I'm going to divide both sides by 6. That cancels. All you have left is W equals, that's top divided by bottom, so it's 144 thousandths divided by 6. 6 will go into 14. 2 times, well, I would put a placeholder 0 there. Subtract remainder 2, bring down your 4. 6 will go into 24 4 times. 4 times 6 is 24. Remainder 0. So your answer is going to be 24 thousandths. Alright, number 7. W plus 5 twelfths equals 1 squared. Well, 1 squared is the same as 1, which is 1 times 1, so I can just say 5 twelfths. W plus 5 twelfths equals 1. What's opposite adding 5 twelfths? Subtracting 5 twelfths. I do it to one side, I have to do it to the other side. 5 twelfths subtracted. Now I'm going to change this 1 into a fraction. 12 twelfths. The reason why is now I can subtract 12 minus 5 is going to be 7 twelfths. This cancels. All I have left here is W. Bring down your equal sign. W equals 7 twelfths.